In this video, we are going to look at the phenomenon of heat transfer, how heat moves from hot areas to cool areas. Have you ever wondered how the sun's heat reaches our planet, or how heat is transferred from one end of the spoon to your hand? Today, we're going to demystify this concept in a way that's as warm and inviting as a cup of hot chocolate. Firstly, it's essential to understand that heat, a form of energy, always moves from a warmer area to a cooler one. This movement occurs in three ways: conduction, convection, and radiation. Conduction is the transfer of heat through a solid material. Picture this. You're holding a metal spoon in a hot soup. The heat travels from the soup up the spoon to your hand. This is conduction at work. Some materials, like metals, are good conductors of heat. On the other hand, materials like wood and plastic are poor conductors or insulators, which is why they're used for the handles of cookware. Next up is convection. This is the method of heat transfer in fluids such as air and water. Have you ever noticed how a room heats up when a radiator is turned on? The warm air rises, then cools and sinks, creating a cycle that spreads the heat around the room. This process is also responsible for land and sea breezes, where the differential heating of land and sea leads to the movement of air. Lastly, there's radiation, which involves the transfer of heat in the form of infrared waves. It doesn't require a medium to travel through, which is how the sun's heat reaches Earth. Different materials have different capacities to absorb or reflect this heat. Dark, matte surfaces are good absorbers, while light, shiny surfaces are poor absorbers but good reflectors. This principle influences our choice of clothing. On a hot, sunny day, you'd feel cooler in light-colored, loose clothing because it reflects heat. Now, let's explore a practical application of these principles. The humble vacuum flask. It uses a double-walled container separated by a vacuum to prevent heat transfer by conduction and convection. The walls are silvered to prevent heat transfer by radiation, keeping your drink hot or cold for a longer period. Finally, we come to the greenhouse effect, a phenomenon linked to heat transfer. Greenhouse gases in the Earth's atmosphere absorb heat radiation from the sun, trapping it and warming the planet. While this natural process is essential for life, human activities have increased the concentration of these gases, leading to global warming. Addressing this requires global efforts to reduce greenhouse gas emissions and enhance natural carbon sinks. In conclusion, the science of heat transfer is not just a fascinating subject, it's a fundamental part of our everyday lives. From deciding what to wear to understanding climate change, the principles of heat transfer continue to shape our world in myriad ways. So, the next time you sip a hot beverage or feel a cool breeze, remember the invisible dance of energy that makes it all possible. We hope it was resourceful. Go ahead and check out other video resources from us on this platform. We hope to see you again soon.